Welcome to today's session on the installation of rootkits. In this lecture, we will explore the fundamental of rootkits, their features, history, and how they function, all within an educational and ethical context. To begin, let's break down the term rootkit. The word root refers to the highest privilege level in a system, much like the administrator in Windows. A kit represents tools that allow unauthorized access to the root level of a computer. These tools operate stealthily, persisting through system reboots and hiding their activities. Rootkits are known for three primary features: stealthy operations, persistent actions, privilege escalations. Their main functions include providing backdoor access to attackers and enabling software eavesdropping, which involves monitoring user activity and intercepting sensitive data. Rootkits were first observed in the early 1990s, primarily targeting Unix and Linux. Over time, they have been evolved to target a wide range of platforms, including Windows and mobile devices. Modern rootkits are highly sophisticated and challenging to detect. Interestingly, not all rootkits are malicious. Legitimate tools like virtual network computing or VNC use rootkit-like functionality for remote administrative control. However, rootkits are widely used for malicious purposes such as intercepting data, installing hidden accounts, and modifying system configurations. To study rootkits ethically, we need a controlled environment. This includes setting up a virtual machine, using sample rootkits responsibly, and employing detection tools like GMER Rootkit Revealer to analyze system changes. This procedure starts by setting up a virtual machine to isolate the experiment. After deploying a rootkit, we analyze its behavior using detection tools. Always conduct such experiments in a safe, isolated environment and never use malicious tools on production systems. Now, these are the steps to download the rootkit tool from GMER website, www.gmer.net. GMER is a widely used tool designed to detect and remove rootkits from your system. The first step involves downloading the software from the official website to ensure it's a legitimate and trusted version. This tool scans for processes, modules, and registry entries that may have been tampered with by rootkits. Once installed GMER, it provides a detailed overview of the system, including running processes, loading modules, services, files, registry keys, and more. This display is crucial for identifying an abnormal or unauthorized changes that could indicate rootkit activity. In the step 3 process, the user navigates to the processes menu within GMER. If any unauthorized or suspicious processes are detected, for example, processes you don't recognize are not related to installed software, they can be terminated to prevent further damage. In the step 4, the modules menu shows a list of system modules. For example, .sys and .dll files loaded into memory. Suspicious or unexpected modules might indicate the presence of a rootkit, as rootkits often hide within such files to evade detection. The services menu. This allows the user to see all system services and their states. For example, whether they start automatically or enabled or disabled or run at boot. Rootkits often disguise themselves as legitimate services, so this step is crucial for identifying and disabling them. The files menu provides access to a complete list of files on the hard disk. Rootkits sometimes hide files within directories or use obscure file names to avoid direction. Reviewing this menu can reveal hidden or malicious files. The Windows registry contains crucial system configurations. Rootkit often modify registry keys to gain persistence or alter system behavior by checking the hkey underscore current underscore user and hkey underscore local underscore machine. These sections users can look for unauthorized changes. These features, GMER performs a detailed scan of selected drives to detect rootkits or malware. It identifies anomalies or hidden objects that standard antivirus type software miss. The Auto Start section shows applications configured to run automatically when the system boots. Rootkits often use this feature to ensure they remain active after a reboot. Any unauthorized or suspicious entry should be removed in this session. In this session, GMER provides the user to the GMER provides access to the system's command prompt for advanced users. This allows for manual inspection or modification of registry entries, execution of commands, and further troubleshooting for detecting and removing rootkits. So now, whenever we are downloading the rootkit from www.gmer.net, then the screen will be look like this. Then here we will go to the processes module. This involves downloading the software from the official website to ensure it's a legitimate and trusted version. This tool scans for processes, modules, and registry entries that may have been tampered by rootkits. So this is the processes modules. This display is crucial for identifying abnormal or unauthorized changes that could indicate rootkit activity. So this is the one of the screenshot which represents the modules, and this is the services. The services menu allows the user to see all system services and their states. These are the files. The file menu displays full files on hard disk volumes. In conclusion, the rootkits are significant security threats due to their stealth and persistence. Understanding their operation helps in developing better defenses. Ethical research in controlled environments is critical for tackling these advanced threats. So this is about the today's session. Thank you for watching this session on rootkits.